All right, so cool story. I just recorded this entire problem and actually I didn't. I forgot to hit the record button, so I just taught this whole thing. So this one's going to be really good. All right, so we are doing practice problem 11.2.1 and it's significance testing, doing a z-test. I'm going to do it start to finish. Here we go. So does the use of fancy type fonts slow down the reading of text? Adults can read 4 paragraphs in an average of 22 seconds if they're reading Times New Roman font. We asked 25 adults to read a text in the ornate font named Gigi, G-I-G-I, not sure how to pronounce that, and their times were given. So if we know that reading is normally distributed with a standard deviation of 6 seconds, we want to know, is there good evidence that reading this fancy font Gigi takes longer than other fonts, 22 seconds? We're going to carry out the appropriate test, that's a z-test, because we know the standard deviation, and answer whether or not Gigi takes longer. So 4 steps, and here we go. So if you want to turn this in to me, feel free to do this on paper and attach it to the document and submit it. Or you can try to work it out with Google Docs, but that's kind of challenging. So here we go. Step 1. Step 1, we are looking for population, parameter, the null hypothesis, the alternative hypothesis, and alpha, the significance level. With alpha, since it wasn't given in the question, we are going to assume a significance level of 0.05. That's kind of our default, 5%. So what is the population? Who are we talking about? We're talking about readers, all readers. The parameter, what are we looking to show? We're looking to show the mean time, the true average time, and we are measuring in seconds. How about the null hypothesis? Our claim is that reading takes 22 seconds. Alternative hypothesis, well, if it's not the same, we think that this fancy font Gigi is going to be greater than 22 seconds, longer than 22 seconds. And again, significance level of 5%. Step 1. Step 2 looks like this. Step 2, we have to have some conditions met. A simple random sample. We have to show normality. And we need to prove independence. So simple random sample, unfortunately, we asked 25 adults, it didn't say if they were randomly selected in any way, so we must assume a simple random sample. It weakens our conclusion at the end. Normality. Lucky for us, it's stated that reading times are normally distributed. We don't quite have enough observations in our sample to make the central limit theorem kick in, so it's good that it's stated. And independence. The question is, are all readers, that's our population, right? Are all readers greater than 10 times 25? I'm going to say, yeah, there's more than 250 people out there who know how to read. We're good to go. Step 1 and 2. Step 3 is our calculations, so let's get on it. Let's remember our formula for a z-test. Z is equal to my sample mean minus my hypothesized null divided by population standard deviation, that's why it's a z-test, over the square root of n. Now, we were given a bunch of observations, a whole lot of different numbers, which I put into my TI-84. Let me show you that. Where are we? Stat. Good online teacher pre-entered the data. So there it all is in L1, all these different observations, how long people took to read 4 paragraphs in the GG font. What I'm going to do here is I am going to calculate the mean. List L1, calculate the mean, and looks like the GG font readers took an average of 27 seconds. That's that value right at the top, the mean. We're not going to use these standard deviations because we were given that in the problem. So let's go ahead and sub those numbers in. So Z equals the sample mean of 27 seconds minus my hypothesized, my hypothesized mean of 22 seconds. I didn't make this mistake in the first video. Divided by the given standard deviation of 6 seconds over the square root of 25. Now I have a couple choices here. I can go ahead and put that into my calculator and figure out what the test statistic, the z-score, actually is, or as I will show you now, I can use my functions of my TI-84 calculator in order to have my calculator figure out my p-value and my z-score. So I'm hitting the stat button. I'm going over to tests, and the very top one, the first option, is the z-test right there, and so I'm going to hit enter. And you have choices between data and stats. If you already know the mean and you know the standard deviation and you know your sample size, all that stuff, you can go to stats. I spent a lot of effort putting in the data into my calculator, and so I'm going to use data. My null hypothesis is 22 seconds. The standard deviation, which was given to me, was 6 seconds. My data is stored in L1, frequency of 1, and then this last part says, it's talking about your null hypothesis, that the mean is not equal to a number, that the mean is less than a value, or the mean is greater than a value. And I'm going to pick that last one because I think GG makes it take longer to read. Okay, so greater than, I hit enter and calculate, enter. And presto, changeo, we've got ourselves some results. And what results they are, holy smokes, I'm going to slide that right there. Z appears to be equal to 4.24, so my test statistic is 4.24 standard deviations. This result that we got is exceedingly rare if it were to happen by random. Okay, looking at my table A, actually this would go off table A, but my calculator shares that the p-value is equal to 1.11. Okay, alarm bells are going off. You can't have a probability over 1. And so I look a little further and I see, to the -5th. That means I need to move my decimal place 5 to the left. So 0.00011. That is a ridiculously small probability. Okay, something's definitely going on. Let's wrap this up in the conclusion section. All right, step 4 is our conclusion section, and it comes to us in 3 parts. We need to have evidence. We need to make a choice. What are we going to do here? And then frame that choice in the context of the problem. So evidence, choice, and context. So what is our evidence? Our evidence is that the p-value of 0.00011 is less than alpha at 0.05. All right, so p-value is wicked small, which leaves me with a very easy choice. Because it's less than alpha, it passes that threshold and allows me to reject the null hypothesis. Reject the null hypothesis. What does that mean? Well, it seems, we really have staggering evidence for this, it seems that GG, that's our font, or Gigi, or however you pronounce that, takes longer to read. All right, cool. There it is, start to finish, all 4 steps.